Everyone, I'm Miss Amruta Zadhav ma'am, your physics teacher, and today we are with part 10 of thermodynamics, in which we are going to deal with air condition, then heat pump, and then second law of thermodynamics. So as you all know that in the previous parts we have discussed all about refrigerator. So I hope you all have done the concept which is refrigerator. By using that concept we are going to explain the air condition and even the heat pump. Okay, so before moving towards the today's session we are going to revise what we have done in the previous lecture. So the basic and most important thing that we have done in the previous lecture was refrigerators, and the first point, which was heat engine cycle and PV diagrams, even that we have discussed in the previous lecture. In that heat engine cycle we have discussed the graph which gives you the idea about it. What is PV diagram, or what PV diagrams gives you actually? PV diagram gives you all the phases which have been changed during the heat engine cycle at a glance. So most of the time we use the PV diagram for the complete and in short information about anything. So that we have studied in the previous one, and the second point was refrigerator. So here you can see the GIF of refrigerator and working of refrigerator, from which you can remember or remind all the terms which are there for the refrigerators. The basic important things for the refrigerators was this. What is that? It is nothing but compressor. So the compressor is very important in refrigerator, and then valves which carries the refrigerant inside the refrigerator. So that is also most important while studying refrigerators. Now I hope you got both the points in the previous one. Now we will move towards today's lecture, which will cover these 3 points. First point is air conditioner, second point is heat pump, and third point is second law of thermodynamics. So these 3 points we are going to discuss in today's lecture. Okay, so basically air conditioner and heat pumps both are very much related and very much similar to the working of refrigerator. So if you have idea about refrigerator and working of refrigerator, these 2 points are very easier to study. So while studying you have to study first all the laws of thermodynamics, then you can move towards the mechanism part of thermodynamics and then towards refrigerator. So step by step you have to study this chapter. You cannot delete or you cannot escape any one of the point. So you have to study whole chapter very clearly and very concentratedly. So I hope you all are doing in such a way. So let's move towards, by considering all these terms in mind, we are going to move towards our first point, which is air conditioner. Okay, so as you all know how the air conditioner looks, you all know that it is in terms of a box and which always out of our window. Alright, so why the air conditioner is outside of a window? There are many advanced technologies in which we can put a AC inside also, which looks like in rectangular form also, and some are there which are in square form, and there some part is outside of the window. You must have seen that. So why so? So after doing so much of research we have come towards very compact machines, and we have discovered many types of machines which are in compact form. But in this part we are going to study the primary one, not the technology or not the compact one. Okay, so we are going to consider that air condition which is outside of the window, which looks from the outside. Okay, so what exactly there inside it? So as we have seen in refrigerator, there is evaporation process is there, then compressor is there, refrigerant is there. So even in air condition we use refrigerant, but the question is, do the refrigerant in refrigerator and refrigerant in AC is same? So the answer is no. Why the answer is no? Because purpose for refrigerant is same. What is the purpose of refrigerant? To refrigerate, to freeze, to cool the air, right? But in case of air condition, the working is somewhat different from the refrigerator. Okay, so let's see what is the difference between them. So the first point that we have to consider while studying air conditioner is, for air conditioner, the evaporator coils are inside the room. The evaporator coils are inside the room, that is to be cool, and the condenser part, which condenses the air and which gives out the hotter part to the atmosphere, are outside of the room. So that's why I'm telling you, this is the reason why we can see the ACs to the outside of our house, because the evaporated coils are inside the room, which gives you the cooler air inside the room, and the air which is hotter one is extracted towards the surrounding or towards the atmosphere. So while we are extracting or while we are removing that air towards the atmosphere, so that part should be outside of the room, so as to maintain the temperature inside the room. So that's why condenser is at the outside of the room. Okay, while we are studying about refrigerator, there is much more difference in refrigerator and AC, because in case of refrigerators, all the temperature which is there inside a single box is, it has to be maintained. But while we are considering AC, we have to maintain the temperature all over the room, which is much more in area. All right, so somewhat it is different. Now the second thing that we have to study about AC is air cooled by the evaporated coils, which is inside the room, and circulated by a fan placed inside the AC unit. So inside the AC unit there is a fan, and it circulates all the air within the room. So it helps to spread the air inside the room. Okay, and the air cooled by evaporators is being spread all over the room by using what? By using the fan. Now, how we are going to define a performance of air conditioner? So the performance that is known as COP is defined by this formula, which is K is equal to mod of QC divided by mod of W. Now what is mod of QC? Mod of QC or QC, we can call it as energy or heat which is been absorbed by the sink, or it is colder one. So that is the heat which is colder one, and W is the work done, obviously. Now we have to consider the rate of heat which is removed from the room and which is being extracted towards the atmosphere. Now what is that? What is that heat which is being extracted? So the rate of heat which is removed is H is equal to mod of QC divided by T, where T is time at which heat QC is removed. Okay, now what is T? Time at which QC is removed. Therefore, COP, which is coefficient of performance of AC, can be mod of QC divided by H by using this formula, which is mod of QC divided by W. Sorry. Now what is QC? From this equation you can, I will write it again so that you will not get confused. So we are having formula for K over here, which is mod QC upon W, which is in mod also. Now by using this, H is equal to mod QC divided by T, we can find out formula for mod QC, which will be H into T. Am I right? Yes. So we can put the value over here, HT. Now what is work? Pressure. What is work? P into T. Now what is P over here? What is capital P? It is power required for removing the heat. So P is nothing but power. So we are getting HT divided by PT. So we can cancel out this term, which is T. Now we are getting the equation as H divided by P only. So COP is nothing but H upon P. What is COP? Coefficient of performance of AC, which is H by P. Now there must be some typical value for that. So typical value for K is 2.5 to 3 for room air conditioners. Okay, so it lies between 2.5 and 3. Now does it have some unit? As we have seen in the previous lecture that K do not have any unit. It is unitless and dimensionless. So here in this case also it is only a number, it do not have any unit. So the value for K is only a number, which is 2.5 or 3. And in case of refrigerator, K is 5 for typical value. Okay, so this is all about AC. Now the next thing which might comes in your mind, that as we say that refrigerator can be measured or expressed in liters. Capacity of refrigerators is measured or expressed in liters. Now how the capacity of AC is expressed? In what terms it has been expressed? Is it expressed in liter, or is it expressed in kilogram, or in grams, or in what terms, or in pounds, or what? So the answer is capacity of AC is expressed in turns. What we say that capacity of AC is expressed in turns. Now why the capacity is expressed in turn? Because before the refrigerators and AC was invented, the cooling was done by coolers. Now how the cooler works? It works on the ice cubes. So the number of ice cubes we are adding to it nothing but in turns. Number of ice cubes which is being melted in a day. Okay, so that's why we are going to, or we used to do even for today, the capacity of AC is being expressed in turns. Okay, I hope you got this answer. Now let's move towards the next point, which is heat pumps. As you all know that, or you have to remind this, heat flows from hot object to a cold object. Is a spontaneous process, right? Heat always flows from hotter object to colder object, but even it can flow from colder object to hotter object, but it has to be done by some work done. So we have to do some work, then and only then it can transfer from colder body to hotter body. Okay, so you have to remember this term while studying refrigerator, AC or heat pumps. Okay, or while you are studying even a first law of thermodynamics also. Now let us move towards our point, which is heat pump. Now you can easily say that heat pump is nothing but a pump which produces heat, right? Or it works similar to refrigerator. So the answer is yes. Not maybe, but heat pump is a device which works similar to the refrigerator. Now what is meaning of similar to the working of refrigerator? That means the cooler part which is maintained inside the refrigerator and hotter part which is outside of the refrigerator. So this is the same way we are going to apply over here. So it is used to heat building or similar large structure by cooling the air inside it. Okay, where the heat pumps are used? It is used to heat the buildings or similar larger structures by cooling the air outside it. In refrigerator, we cool the surface which are there inside the fridge, and hotter part will be there at the outside. So it can be reverse. hotter part will be in the inside and cooler part will be outside. So we are going to extract the cooler part. Okay, so the heat pump works like a refrigerator operating system, operating inside out. In this case, the evaporated coils are outside. Now, in this case, the evaporated coils are outside, and the absorb heat from the cold air from absorb outside. Okay, what I'm telling you, the evaporated coils are outside and absorbs heat from the cold air from outside. It is absorbing the heat from outside and giving it to the inside. Okay, so this is what heat pumps does. The condenser coils are inside the building. They release the absorbed heat to the air inside. So as the condenser is increasing or decreasing the pressure and increasing the temperature, so it gives heat inside the buildings or inside the any area in which we want a warmer surface, warmer atmosphere. There it is pushed, and then the air inside it will get warmer, so we can warm the building. Okay, so this is all about the heat pump. Now, after studying the first law and the application of first law, which was refrigerator, AC and heat pump, we are going to study second law of thermodynamics. But why to invent the second law? Because there are some limitations for the first law of thermodynamics. We come to know that after some time, many scientists come to know that there are some limitations for the first law of thermodynamics. So we have to derive the advanced law for the same, so that the advanced part of the thermodynamics law, which is second law of thermodynamics. So what limitations we come over, so that we have to find out the second law. So let's see what limitations we came across. So the first limitation which comes across is, while studying first law of thermodynamics, we used to say that all the heat which is there inside the system converts into internal energy as well as work done. Or we can say that heat which is absorbed is converted into work done. So is it really possible that all the amount of heat which is given to the system is converted completely into work done? So the answer is no, and we don't have any explanation about it. So it does not tell us whether any particular process can actually occur. We don't know the actual process of that. So this is the first limitation of thermodynamics first law. Okay, according to the first law of thermodynamics, heat may or its own flow from object at higher temperature to one at lower temperature, and it can also own or temperature at one at higher temperature. Or we can say that heat always flows from higher temperature to lower temperature, and in practical it is possible, and it is true. But the first law of thermodynamics does not predict the practical observation for the same. Okay, so this is the first limitation which comes across. Now, what was the second limitations which come across? The second limitation was, as we have discussed, according to the first law of thermodynamics, we could convert 100% of the heat available to us into work. Similar, all the work could be converted into heat. Again, we know that practically this is not possible, because all the heat which is given to the system cannot be completely converted into work done, or not in inverse. So this is not practically true. So thus, first law of thermodynamics does not prevent us from the converting heat entirely into work or work entirely into heat. So these limitations led to the formulation of another law. So the scientists find out the another law which is second law of thermodynamics, which gives you some idea about the limitations which we have come across. Okay, so let's see what this second law is actually giving us. So as we know that it is not possible to build a heat engine that can completely convert heat into work. Is it right? Yes, that is, I am saying it again, it is not possible to build a heat engine that can completely convert heat into work, because some amount of it is being given out to the atmosphere, or some amount of it is being there inside the system as a internal energy. So not the 100% of it energy is uses for the work done. So perfect engine or perfect heat engine is not there. Even for the refrigerator it is not possible. Okay, so to remove these all limitations we come across to the second law. Now we are moving towards the statement of it. Now what is the statement of second law of thermodynamics? So here is it. It is impossible to extract an amount of it QH from the hot reservoir and use it all to do work W. Is it true? Yes, it is impossible to extract the amount of it QH from hot reservoir and use it all to do work, because it is impossible. Not all the heat is being converted into work. It is not possible, because some amount of heat, which is QC, must be exhausted to the cold reservoir. This prohibits the possibility of perfect heat engine. Now what is the role or what is the aim of perfect heat engine? The amount of heat which is given to the engine should be converted all the heat to the work done, which is impossible, and it is given by the second law. So that is gives us the idea about the heat engine. So that's why it is also known as engine law or the engine statement. Even this gives you idea about the temperature. So even the another law or the another statement on another form of statement is known as Kelvin-Planck statement, because it is being derived by scientist Kelvin and scientist Planck. So that's why it is named after them. So what is that? It is not possible for heat to flow from colder body to a warmer body without any work having been done to accomplish this flow. So in this statement we are only talking about the temperature. So that's why it is the another form of the statement, which is Kelvin-Planck statement. What it tells us? It tells us that heat cannot be flow from colder to warmer body without any work done. We have to do some work on the body, then and only then it can flow from colder surface to the warmer surface. Okay, so this is being given by, or this is being explained by Kelvin and Planck. So it is being named after them. Okay, so this is the another form of second law of thermodynamics. Now we are going to move towards some schematic diagrams of engine and even for refrigerators. So let's have a look toward it. The first diagram, in which you can see over here, hot reservoir is there, cold reservoir is there. The heat, some of the heat is given to the cold reservoir and some heat is being converted into work done. So this is nothing but the second law. And in this is the ideal diagram for ideal heat engine, in which all the heat which is being converted into work done. This is according to the first law, which is actually not true. By this diagram we can say that all the amount of heat is converted into work done, because there is no any arrow towards the cold reservoir. Okay, so this gives you the exact idea about first and second law. Right, now we'll move towards the another schematic diagram, which is for refrigerator. Okay, now what is the perfect refrigerator? In perfect refrigerator, this should be there. Hot reservoir at TH and cold reservoir at TC. Okay, so heat which is given out by this is QC, which is given out to the hot reservoir QH. So this will continues to be in a cyclic process, cold to hot from QC to QH, colder to hotter. So this is for the perfect refrigerator, refrigerator, and but it is not practically true. Practically we are getting this. W has to do work, then and only then the body which is from colder part will move towards the hotter part. So the heat flows from colder to hotter by doing some work on it. So this is by the second law. Okay, in this what we can see, heat is flowing from colder part to hotter part. But is it true? No, it is not true. Why it is not true? Because we have to do some work on it. So by doing work, that heat will be converted into hotter one. So this is the second law. Okay, so the statement means that the spontaneous flow of heat from object at colder temperature is not possible. We have to do some work on it. So even this is the second form of the statement, which is known as Clausius statement. Why Clausius statement? Again, or we can call it as refrigerator law also, as the first law is denoted, or the first form is known as engine law. This is known as refrigerator law or Clausius statement, because it is being invented by the scientist whose name is Clausius. Okay, so this is all we have discussed today, and that was really very easy to understand. I hope you got all these 3 points while the video is playing. First one is air conditioner, which is very easy and it works exactly opposite to the refrigerator, because compressor is at the outside and evaporated air is inside. So this is about air conditioner or AC we can say. Then heat pump we have discussed, which works similar to refrigerator, and second law of thermodynamics that we have seen. Even the second law of thermodynamics has some form. The second law of thermodynamics is also known as Engine's law. It is also known as Kelvin's and Planck's constant law, and even refrigerator law. Right? So there are 2 forms. First form is Kelvin's and Planck's statement, which gives you idea about the engine, and second form is Clausius statement or refrigerator law, which gives you idea about refrigerator. So this is all of second law of thermodynamics. So I hope you all got this idea of all the 3 points, and still if you have any query about it, please do ask me. I will solve your query. So thank you for watching whole video. Thank you so much all of you. Keep watching.